Hello, this is Dr. Mears, and this is like the 16th time I'm making this because I kept messing up. So I'm actually making this in Core 1. Say hello, everybody.
Hi.
Awesome. Seniors, graduating soon. Okay, so I'm going to miss you all, but we do have to get this done before we can get and go. So here's your outline, and this is the video for my game. And what my game does, which I forgot to get my things for, my game involves one die and a deck of cards. And so this is how we play my game. First, you roll the die. If you get a 1 or a 2, you lose. If you get a 3, 4, 5, or 6, you win. So we roll it 1. Okay, I lost, so it was $2 to play, which means I lost my $2. But hey, guess what? I get to go again. So I pretend give my $2. All right, let's go. I need a 3, 4, 5, or 6. Let's go. 3. Yay! I get to move on. That means we go to the deck of cards. I can shuffle this deck. I can cut this deck. But what I need from this deck of cards is to pull 2 cards, no replacement, and have them be black. So if this first one is red, I lost. Okay, ready? Here we go. Hopefully it's black. Darn, I lost. So they would have had to pull 2 cards, and both of these, they're both red, that's funny. Both of these cards needed to be black to win the game. And to win the game, you win $5. That means you get your 3 back. So writing this up in an outline, I'm going to go step by step with you to show you what it looks like. Number 1, what are the rules for the game? So I know you did this on your proposal, but I'm asking you to write it in definitely more detail. Notice I didn't type it up. That's absolutely fine. So rules, it's a win-win world. $2 to play. Round 1, roll a 6-sided die. Win. 3, 4, 5, 6, lose, 1, 2. Round 2, shuffle or cut the cards. How many cards there are, how to win or lose. If you win round 2, you receive $5. That means you get $2 back and make 3. This is very important because we're going to be using that. So you have to remember what they're winning or losing. If you lose round 2, I keep your $2, or lose round 1, I keep your $2, which means you lose. So that would be a profit of -2 for you. And so that's going to come into play. So these 2 numbers we're going to need. Okay, what's next? 2, list all the outcomes of your game and the associated prize amount for each outcome. Use a tree diagram. So here is my tree diagram. And so what I did for this is I set it up into round 1, round 2. Round 1 is my die. Here's my 4 out of 6, 4 numbers out of 6 numbers to win. 2 numbers, 1 or 2 out of 6 to lose. If you lose, you're -$2. You lost that $2. Then, if you win your round 1, you can go on to your round 2. Round 2 is out of 52 cards here. 26 are black, 26 are red. You need your first card to be black to move on. If not, you lose, -$2. So please notice I have everything in there. Then you go on. This is basically like round 3 up here. You win if you pull another card. Now, because it's without replacement, that means there's only 25 cards left that are red out of 51 cards that are left because I kept that 1 card out. There's still 26 red out of 51 cards total. You win if your second card is black. Now, you win $3 because you just, and look at my little math right here, you paid for playing the game $2 and you won 5, so you came out with 3. So you win $3 here, you lose 2, you lose 2, you lose 2. So this is my tree diagram. From my tree diagram, I'm going to go to number 3. Number 3 is make a table to represent the following. 1, each outcome, 2, each prize amount, and 3, the probability of each prize amount, both as a decimal and percent change. So we need to change this tree diagram into a table. And magically, it looks like this. But how did I get this? So let's first look at this. How I set it up. Outcome, outcome, prize amount, and probability, both in a decimal and percent change. So my first outcome is win, win, win. So let's look at that. What path did I take? I took this win path, which is 4 out of 6, to this win path, which is 26 out of 52, to this win path, which gets me to my $3, and that was 25 out of 51. So these 3 fractions I am going to multiply. Notice I didn't reduce, I just multiplied across and then divided it out. That's absolutely fine. And so I got 0.1634, so I have a 16% chance of winning $3. How about my win, win, lose? So that is this one, win, win, lose. So again, it's going to be this fraction times this fraction times this fraction here, and that gets me to my minus 2. So minus $2 are these three fractions multiplied, divided out, and you get about 17%. You may round to the nearest percent. My win-lose, this was my win to lose branch, so remember multiplying these. And then I just have my lose, which is just, that was when I rolled that one. I had a 1/3 chance, 0.333, of losing $2, and that's what I did here. So 33% chance of losing. So you're basically turning your tree diagram into a nice table. And this table is going to help you do the next part, which is creating a bar graph that shows the probability of each outcome. So what does that look like? So my bar graph is going to upside down. Woo, dizzy. Okay, there we go. Bar graph. It's a win-win bar graph. I labeled it. I put outcomes on the side, probability. Sorry, outcomes on the bottom, probability on the side. And I just went by 0.1, 0.1, 0.2, 0.3, 0.4. And I put my outcomes down here and then where my bars go. And notice I just did this by hand. You can use software. You can use Google Sheets. You can use Excel. That's fine. I did a sketch by hand. I just wanted to see what the probability distribution looks like. Well, for here, win, 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 that we know, we can see clearly that it's the smallest. So I just took my outcomes here and my probability as a decimal, so this one, and I just made a graph from it. And so there's my bar graph, which is kind of neat because you're going from your tree to your table to your bar graph. Let's see what we're going to be doing next. Number 5. Calculate the expected value. The expected value is the average amount of money a person will win if they play your game many, very many times. So let's see what that looks like. Expected value. So here we go. Expected value is each prize amount times the probability plus each prize amount times the probability plus each prize amount times the probability. So basically what you're doing is multiplying each prize amount with its probability and adding them all up. Kind of feels like we're doing the mean, doesn't it? Which we are. So here we go. Here's my expected value. So going back to my nifty old table, I have 3 times its probability. So winning $3, this is the probability, and I just got that. Winning $3, this is its probability. So I just multiplied the 3 times 0.1634. Winning negative $2, which means I lost, negative 2 is 0.61699. And so on and so forth down the line, each one multiplied by its probability. I change those into decimals so I can show how I'm doing my mathematical computation. And then I got negative 1.1828. I'm going to round to the nearest hundredth because we're working in money. So it's negative $1.18 or Mears monies. If a person, here's my explanation, if a person plays my game many times, they're expected to win on average, and that's your key word, it's an average, because it is, on average, negative $1.18. So basically, if you play my game many times, you're going to, on average, lose $1.18. Sorry. So that means that the casino is making money. All right. So on average, playing many times, you're losing. Sorry. That's just the way life goes. Okay, here we go. What's next? If a person plays your game 50 times, how much money will a person expect to win? Does this person lose money or make money? So just going to number 6 here, all you do is you take your expected value and multiply it by 50. So that's about $59 loss. That's a lot. That's like, oh my goodness. So if a person plays your game 50 times, the person will expect to win negative $59. Oh my. Therefore, Aunt Sally, the person, will lose money. Probably have to go back to that bank to get some. It's expensive when you take money out. All right, what's the last one? Number 7, if a person plays your game 50 times and loses each time, how much money will your booth make? So all it is, $2 to play, $50 times, $2 to play 50 times. Multiply the cost to play by 50, it's 100. So the booth will make $100 if a person plays 50 times and they lose every single time. So that is it in a nutshell. If you need to go back and review it, pause it, play it again, and I will totally miss all of you. You guys were my ultimate favorite ever, and happy graduation. See you later. Come and visit. You know